So, what's up everyone, Sophia here and welcome back to the channel. Today, we're diving into a topic that I've been getting a ton of questions about lately. It seems like everywhere you look in the tech world, from giant corporations to the smallest startups, there's this massive, growing buzz around one specific role, the data scientist. It's been called the sexiest job of the 21st century, and for good reason. Companies are swimming in data, and they desperately need people who can make sense of it all, find the patterns, and turn those insights into actionable strategies. It's a field that's not just in demand, it's exploding. The thing is, with all that hype comes a lot of noise. You see these job postings asking for PhDs and 10 years of experience, and it can feel pretty intimidating, almost impossible to break into. Where do you even start? What do you learn first? It's easy to get lost in a sea of online courses, boot camps, and conflicting advice. The path forward can seem incredibly murky, and that paralysis of not knowing the next step is a real thing. But it doesn't have to be that complicated. There is a structured way to approach this, a path you can actually follow. That's exactly what this video is for. I want to cut through all that noise and give you a clear, straightforward roadmap. Think of this as your step-by-step guide. A blueprint for getting started on your journey to becoming a data scientist. We're going to break it down into 5 key milestones, from the absolute fundamentals all the way to building a portfolio that will get you noticed. So if you've been curious about data science but didn't know where to begin, you're in the right place. Let's get into it. Alright, first things first. Before you can analyze data, you need to be able to speak its language. And in the world of data science, that means learning to code. Now, you could technically go a few different routes here, but really, the conversation boils down to 2 main players. Python and R both are incredibly powerful open source languages with massive communities and extensive libraries built specifically for data tasks. Honestly, you can't go wrong with either one, but if you're just starting out and want my recommendation, I'd lean towards Python. It's known for its clean, readable syntax, which makes it a bit more beginner-friendly. The versatility of Python is just unmatched. It's not just a data language, it's a general-purpose language used for web development, automation, software engineering, and so much more. This means that learning Python opens up a ton of doors beyond just data science, making it a super valuable skill to have in your tech toolkit. When you're starting, don't get bogged down trying to become a master software developer overnight. Focus on the fundamentals, variables, data types, loops, conditional statements, and functions. You need a solid foundation to build everything else on. Think of it like learning the grammar of a new language before you try to write a novel. There are countless resources out there to get you started. Websites like Codecademy, FreeCodeCamp, and platforms like Coursera or edX offer fantastic introductory courses on Python for data science. The key here is not just to watch videos or read tutorials, but to actually write code every single day, even if it's just for 15 to 20 minutes. Open up a Jupyter notebook or a code editor and start experimenting. This hands-on practice, this muscle memory of typing out the syntax and seeing it work, or more often, debugging why it doesn't work, is what will truly solidify your understanding and build that crucial foundation for everything that comes next. So, once you have a decent handle on the basics of Python, it's time to level up and start working with the tools that data scientists use every single day. This is where you learn how to actually manipulate, clean, and explore data. And for that, you'll need to master a couple of core libraries. The first one, and arguably the most important, is Pandas. Pandas is the undisputed king of data manipulation in Python. It introduces a powerful data structure called a data frame, which is essentially a table, like a spreadsheet, that you can control with code. This is your workhorse for cleaning messy data, handling missing values, filtering for specific information, and reshaping your data into a usable format. Alongside Pandas, you'll almost always be using NumPy, which stands for Numerical Python. NumPy is the fundamental package for scientific computing in Python. It provides support for large, multi-dimensional arrays and matrices, along with a collection of high-level mathematical functions to operate on these arrays. While Pandas is built on top of NumPy, understanding how NumPy works under the hood is super important, especially for performance. It's the engine that makes a lot of the high-speed data crunching possible. Getting comfortable with creating NumPy arrays and performing vector operations will make your data analysis workflows much more efficient. But here's the thing, numbers and tables are great, but they don't always tell the full story. As humans, we're visual creatures. That's where data visualization comes in. And it's a skill that separates good data scientists from great ones. You need to learn how to turn your findings into compelling charts and graphs. The go-to libraries for this in Python are Matplotlib and Seaborn. Matplotlib is the foundational library. It's incredibly powerful and gives you granular control over every aspect of your plot. Seaborn is built on top of Matplotlib and provides a high-level interface for drawing attractive and informative statistical graphics. Learning how to create bar charts, histograms, scatter plots, and heat maps is non-negotiable. This is how you'll uncover insights and communicate your findings effectively. Okay, let's talk about something that can sometimes scare people away from data science, the math. But here's the truth. You don't need to be a pure mathematician with a PhD to succeed. However, you absolutely need to have a solid intuitive understanding of some core mathematical and statistical concepts. These concepts are the theoretical bedrock upon which all data analysis and machine learning models are built. Without this foundation, you're just plugging numbers into black boxes without really understanding what's happening, which is a recipe for disaster when things go wrong. The first major area is probability and statistics. This is the heart of data science. You need to be comfortable with concepts like probability distributions, descriptive statistics, mean, median, mode, standard deviation, and inferential statistics. Understanding things like hypothesis testing, p-values, and confidence intervals is crucial for making sound conclusions from your data. It's what allows you to go from saying, "This data point is interesting," to "We are 95% confident that this new feature increased user engagement." This is how you quantify uncertainty and make data-driven decisions. The other key area is linear algebra. Now, you don't need to be able to do complex matrix proofs by hand, but you need to understand the concepts. So much of data science, especially machine learning, represents data as vectors and matrices. Understanding what vectors, matrices, dot products, and eigenvalues are will give you a much deeper intuition for how algorithms like linear regression or principal component analysis actually work. It's the language that machine learning models use to see the data. Grasping these fundamentals will demystify the algorithms and empower you to use them more effectively. Again, platforms like Khan Academy and 3 Blue 1 Brown on YouTube are incredible resources for building this intuition visually. Now we're getting to the really cool stuff, machine learning. This is often what draws people to data science in the first place, the idea of building models that can learn from data and make predictions. Once you have your programming, data manipulation, and math foundations in place, you're ready to start exploring this world. The best way to start is with a library called scikit-learn. It is, without a doubt, the most user-friendly and comprehensive machine learning library out there for beginners and experts alike. It provides a clean, consistent interface for a huge range of algorithms. With scikit-learn, you can start exploring the fundamental types of machine learning. You'll want to get hands-on with supervised learning, which includes regression tasks, predicting a continuous value like a house price, and classification tasks, predicting a category, like whether an email is spam or not. You should learn classic algorithms like linear regression, logistic regression, decision trees, and support vector machines. You'll also want to explore unsupervised learning with algorithms like k-means clustering for finding natural groupings in your data. Scikit-learn makes it incredibly easy to train a model, evaluate its performance, and tune its parameters. Once you're comfortable with the fundamentals in scikit-learn, you might want to explore the world of deep learning. This is where the heavy hitters like TensorFlow and PyTorch come in. These are more complex frameworks used for building neural networks, which power everything from image recognition to natural language processing. You don't need to master these on day one, but getting some exposure is a great idea. Start with a simple project, like building a neural network to classify handwritten digits from the famous MNIST dataset. The key is to start applying the theory you've learned. Don't just read about the algorithms, import them, fit them to data, and see what they can do. This final step is arguably the most important one of all, and it's where everything we've talked about comes together. You can take all the courses in the world, but nothing proves you have the skills like actually building something with them. You need to get your hands dirty with real-world projects. This is how you'll truly learn. You'll encounter messy data that needs extensive cleaning, you'll have to make decisions about which model to use, and you'll face challenges that tutorials just don't prepare you for. This practical application is what transforms theoretical knowledge into practical expertise. So, where do you find data to work with? There are amazing resources out there. Kaggle is a fantastic platform with countless datasets and competitions. You can also find interesting data on government websites through APIs from companies like Twitter or Spotify, or by scraping your own data from the web, which is a great skill to learn in itself. Pick a topic you're genuinely interested in: sports, movies, finance, social media trends, whatever. When you're passionate about the subject matter, you'll be more motivated to dig deep and uncover interesting insights. Start with a clear question you want to answer with the data. Finally, and this is crucial, you need to showcase your work. A portfolio is your resume in the world of data science. Create a GitHub profile and upload the code for your projects in well-documented Jupyter notebooks. Even better, write a blog post or create a personal website to explain your project. Describe the problem, your methodology, the challenges you faced, and your final results and visualizations. This demonstrates not only your technical skills, but also your ability to communicate your findings. A hugely important skill for any data scientist. A portfolio of 2 or 3 solid end-to-end projects is infinitely more valuable to an employer than a list of completed online courses. It's tangible proof that you can do the job. And that's the roadmap. 5 clear, actionable steps to take you from zero to building a real data science portfolio. It's a lot, I know. It's not a path you can complete in a weekend, but it's not magic either. It's a journey of acquiring specific learnable skills one at a time. The most important thing you can do right now is to just start. Don't wait for the perfect time or the perfect course. Pick step 1, learning the basics of Python, and commit to spending a little bit of time on it today. That's how momentum is built. The secret ingredient to success in this field, or any complex field really, is consistency. It's not about cramming for 12 hours one day and then burning out for a week. It's about the compound effect of showing up every day, even if it's just for 30 minutes to write a few lines of code or read a chapter about statistics. That consistent effort is what builds lasting skills and deep understanding. Remember, this is a marathon, not a sprint. Be patient with yourself, embrace the challenges, and celebrate the small wins along the way. Every error you debug is a lesson learned. I truly believe that anyone with the curiosity and the drive can follow this path and build an amazing career in tech. The resources are out there, and the demand for these skills is only going to grow. I hope this video gave you the clarity and motivation to take that first step. If you found this helpful, definitely hit that subscribe button and turn on notifications. I'll be sharing a lot more content on tech, career development, and breaking down complex topics just like this one. Thanks for watching, and I'll catch you in the next one.